We want to factor x squared plus 19x plus 60 using the diamond method. So remember the diamond method for a polynomial form x squared plus bx plus c. You do your x here, c goes here, b goes here, x, and then we have a factor here and a factor here. Okay, and our goal here is to find factors of c that add to b. Okay, it makes more sense with an example, so let's just dive in here. So here we go. Here's our magic x for this example. We put a 60 here, 19 goes down here. All right, then we have our x's. Okay, so we want to find factors of 60, factors of c, that add to, in this case, b is 19. Okay, so let's start listing factors of 60. So maybe you can do this quickly. Maybe you just need to start at the beginning. 1 times 60. Well, those don't add to 19 in any way. 2 times 30. Nope, not even close. 3 times 20. Well, that's closer. We could do 23 or maybe 17 if we messed with the negatives a little bit, but still not doing it. Okay, 4 times 15. Yes, because 4 plus 15 is indeed 19. All right, so we put our 4 here, our 15 here, and these are both positive. Okay, so then this makes our factors x plus 4, x plus 15, x plus 4, x plus 15. And you could FOIL this together to check it. Maybe we'll do a mental FOIL, x squared. First, outside 15x, inside 4x is 19x, plus 4 times 15 is 60. Yes, you could write out that FOIL too. You always can FOIL it to check. You don't always have to. If you've done this correctly, it'll give you the correct factors. Let's try another one. Here we have x squared plus 4x minus 32. We want to factor this. Let's use the diamond method. So we draw our x. Some people call this the magic x method. Okay, remember c goes up here, so negative 32 goes here, and b goes down here. 4, put my x's in. Okay, so we need factors of negative 32 that add to 4. Okay, so let's do it. I'm just going to do 32, and then we can kind of feel out the negatives and positives as we go. 1 times 32 doesn't do the trick. That doesn't get us close to 4. 2 times 16, closer, but still not quite there. Right now, I'm mentally doing 16 plus 2, 16 minus 2, 2 minus 16. Just trying to see if there's any way we can add or subtract these to get to 4. Well, 3 doesn't divide 32. 3 is not a factor of 32. Let's do 4. 4 times 8. Now we're talking. 4 times 8, right? Because this is actually going to be negative 32, and we can do, to make it negative, we just need one of these to be negative. We want this to be a positive 4, so I'm going to make this negative 4 times 8, because 8 plus negative 4 is 4. Right, so add to 4, which is what we did. These terms added to 4. Okay, so we have a negative 4 here, a plus 8 here, and then reading off like this gives us our factors. So we have x minus 4 and x plus 8. Okay, let's give this one a quick FOIL check just to make sure we haven't gone awry here. Let's see, so first x squared outside plus 8x, inside minus 4x, last minus 32. Simplify it down, x squared plus 4x minus 32. Yes, that's what we're looking for. So right here is our factored form. Let's try another example. X squared minus 7x plus 5. All right, diamond method it is. Here we go. We put our c term down here, c term up here, 5, b term down here, negative 7, and we write in our x's. So we want factors of c that add to b. Here's our c, here's our b, this negative 7. So factors of 5 that add to negative 7. All right, so let's see how we can factor 5. Well, 5 is prime, so we have 1 times 5, 5 times 1, which is the same. If we add those, we only get 6. There is no way to factor 5 such that we can add the factors to get negative 7. Impossible. All right? So when that happens, we say prime. That means that this polynomial, this trinomial, x squared plus 7 or minus 7x plus 5 can't be factored. It's like a prime number. Like this 5 can't be factored. I mean, it can. It's 1 and 5, just like we could factor this to 1 times the polynomial. 1 is technically a polynomial as well. But other than that, it can't be factored. So this thing here is prime.